This is a journey through space and time, both above the ground and below, from the present into the past and back again. It is all part of Marble Arch Cave's European Geopark. We're going to travel underground to catch a glimpse of one of Europe's most unique cave systems, and also look down from above at the landscape and countryside of Quilca Mountain in southwest Fermanagh. Using the magic of modern technology, we will fly through time itself, and from the comfort of our seats, look down at the scenes as they would have looked many millions of years ago in the distant past. We will uncover some of the mysteries of this unique underground cave system. For example, the mystery of rivers on their journey down the mountainside, which quite suddenly vanish. We will unfold the mystery of how enormous caverns, some the size of large churches, came to be formed by nature under the surface of the ground, and how these rocks, though they look so permanent, are still changing as we watch today. The Marble Arch Caves are a series of chambers, 3.5 miles or 5.6 kilometers in length. They lie along the course of the Clara River, which runs underground for part of its journey to join the Arnie River before entering lower Loch Macnean. If we could look beneath the surface of the earth, we would see how the caves lie on the lower slopes of Quilca Mountain, sometimes quite close to the surface, at other points some 55 meters underground. To understand how these chambers came to be formed, we need to go back in time to an almost incomprehensible 340 million years ago, when the island of Ireland lay on the equator. Looking down from above at this part of County Fermanagh then, it would have looked something like this. Daily midday temperatures for winter then would have been 30 degrees centigrade, and a warm tropical sea covered the area and around 1/12 of the Earth's entire surface. Under the sea, however, the building of the Geopark had begun, with lime-rich mud being formed from the shells and remains of millions of sea creatures. Layer upon layer of this material became limestone. Now and then, a change in seawater chemistry, possibly due to a change in sea temperature or a drop in sea level, disrupted the formation of the lime-rich mud, resulting in both horizontal and vertical weaknesses, known as bedding planes and joints. We know all this by the evidence of the many fossils of sea lilies, corals, and other sea creatures found in the rocks today. But the surface of the Earth has undergone many dramatic changes since that time. Eventually, the seas over this part of the world receded, and over the next 300 million years, the limestone rock became covered as a result of other geological processes. Great upheavals in the Earth's crust have since brought the limestone rocks back to the Earth's surface, leaving them exposed to the ravages of the elements. Great changes in the climate have come and gone, including periods of Arctic weather during the last ice age, being interspersed with warmer spells, such as is happening today. About 20,000 years ago, during the coldest part of the Ice Age, Quilca Mountain was covered with great sheets of ice. What had been tropical ocean was now a sea of snow and ice. As the Ice Age came slowly to an end some 10,000 years ago, large herds of deer and reindeer moved across the ice in search of grazing, followed by nomadic hunters and wolves. The emerging land was quickly covered by plants, similar to those found growing in the tundra regions of Scandinavia today. The melting ice also swept large quantities of rock, gravel and sand into the caves, in some instances blocking them. So it is quite possible that many cave systems lie undiscovered to this day. The great forests were the next to appear, some 8,000 years ago. First with pine trees, and later alder, oak and ash were common in this area. These woodlands supported a rich variety of wildlife on the forest floor, including man, and the bones of Neolithic man and his simple tools have been found in this part of Ireland. The lime-rich mud laid down by the shallow tropical sea had been compressed into solid limestone rock. Under the microscope it looks like this, a mass of interlocking crystals tightly held together